In factors affecting solubility, let's understand effect of temperature on solubility. In this, we have got to understand enthalpy of solution and Le-Chatelier's principle. In enthalpy of solution, we have got to understand exothermic and endothermic reactions. Now, in case of endothermic reaction, let's understand what happens. Now, this whatever is there is the energy profile. All right. Here, what we have is reaction coordinate. This is reaction coordinate, and this is about energy. All right. Now, so let's understand. Suppose the graph goes this way in this case, and in this case the energy profile goes this way. Now this is what we call as enthalpy, that is H. This is what we call as enthalpy of reactant, and this is what we call as enthalpy of product. Even here this is enthalpy of reactant, enthalpy of product. Now regarding these things, I have separately explained endo-exo clearly. Here I am just doing a rough explanation required for our understanding. Now del H in this case would be HP minus HR. Now whether it would be positive or negative. Now HP comes here, which is lower than HR. So obviously del H would be negative. Whereas when we observe over here, this is what is HP and this is what is HR. So del H, that is HP minus HR, would be positive. Alright. Now what do we understand? Now when it is like this, that means the reaction, now this was the energy which was present in the reactant. But when it formed the product, it gave out that much of energy. So this is what is exothermic. So in this reaction, heat would be generated and the system would get heated up. Whereas in case of endothermic reaction, now this was the energy possessed by a reactant. Now it and the product has this much energy greater than that of a reactant. So it has taken energy from the system. Now since it has taken energy from the system, so this is endothermic reaction, and since it is endothermic reaction, so the system gets cooled. So that is about exo and endo. Now in case of KCl, we observe that KCl, when dissolved in water, it forms KCl solution, aqueous solution. Now dissolution of KCl in water is an endothermic process. Now endothermic process means del H is positive. Now if del H is positive, that means this is the situation. So it has absorbed heat and the system has got cooled. Alright. So now let's understand Le-Chatelier's principle before we move further. Le-Chatelier's principle is principle of stress buster. Principle of stress buster. So now we have heat over in this. So when we come to this part, now this is what is enthalpy of reactant. This is what is enthalpy of product. So when we dissolve KCl in water to form KCl aqueous, it absorbs heat from the system, as a result of which the system gets cooled. Now as already mentioned, Le-Chatelier's principle is stress buster. So keep one thing in mind, if this reaction is endothermic, then the backward reaction is always exothermic. So exothermic reaction means this. So in this case, heat has been liberated. This much heat has been liberated. So this process would be, if I go backward, then this process would be del H would be negative. That is heat generated. Alright, so the system would become hot. So if I apply heat over here, what is going to happen? Already heat is there. So when you apply further heat, the reaction would move in this direction. Why? As per stress buster, already stress of heat is there over here. Further stress, if we apply of heat over here, the reaction would move in this direction, as a result of which we expect all the endothermic reaction to move into this direction on heating. Thus, as a result, we expect solubility to increase in case of endothermic reactions with rise in temperature. Alright, solubility increases with rise in temperature as per stress buster or as per Le Chatelier's principle. As already heat is there, more heat provided, so it would move towards this direction. Following the same line, in case of exothermic reaction, we expect the solubility to decrease with rise in temperature. Alright, but now this is not the trend which we observe always. There's no direct correlation between solubility and exothermicity and endothermicity.